Thank you all very much. At this point, I would usually ask if the people at the back can hear me, but that's kind of a rhetorical question. That's kind of like asking a UDP joke, but I'm not sure if you all get it. Anyone? No, not a whole lot of people got that one. But anyway, I'm Taz Singh, and this is the most hipster picture of me I could possibly find. For short, you can call me Taz. You can spell it like that, not like with the S or whatever. And I'm from Toronto, Canada, where I've been writing various different types of software for the majority of my life. And one of the more relevant things I did over there was actually start up Toronto.js. So if you're ever in town, check out one of our 35 events a year. We actually grew to be one of the largest developer communities in Canada. And a few of the guys from Pusher were actually there at one of our events. So good to be here in their office in London, where I guess we're kind of trading. They came to Toronto, I came to London. But anyway, earlier this year, I moved to London to work with a company called Mainframe to build the next generation of communication software. And while I was talking to them back in Toronto, they told me that they actually build for a bunch of different platforms off the same code base. And I'm like, I'm a pretty skeptical guy, and I was pretty skeptical whenever someone tells me that. I'm like, does it actually work? Like, is it any good? Because whenever someone tells me something like that, I think of technologies like Java Spring, like Xamarin, like Flash, like PhoneGap more recently. And they're all kind of like this. They're all kind of like this world-class rally SUV that can take on a harsh desert terrain. And at the next moment, can take you through waist-deep muddy waters. And if that's not enough, can plow the road ahead of you with snow and even take you on that road. And that's what they all kind of want to be, but in practice, they end up being something like this. I mean, it's still technically an SUV, and it might be able to do some off-roading, but I don't think it can do any of the things I just mentioned, and it's kind of a shitty Pontiac Aztek. It's certainly not a world-class rally vehicle. Sure, it can take you from point A to point B, but it's not really a great experience while doing it. And if that wasn't making your eyes bleed enough, here's a higher resolution side view. So you can check out those sweet side vented exhausts and like those chrome rims. And is that a rear tail diffuser I see? Is this thing seriously generating enough downforce that thing actually be useful? I mean, whoever put this thing together must think this thing looks amazing. But for the rest of us, we're just laughing at them. And this is really a similar experience that I feel to those frameworks I just mentioned. I mean, whoever built those, whoever's using those, I'm sure whoever developed those thinks it's amazing, but for us users that are actually using them, it's just not quite right. And that's fundamentally because they're kind of these write once, run anywhere frameworks. What they want to do is you basically write your code once, and the library itself will manage actually targeting all those different platforms. And they generally don't quite do it in the right way. Sure, they might give you some if-else statements or some sort of compiler macro, so you can kind of drop down and kind of tailor fit it for yourself. But overall, I haven't really been convinced with any of these, and I haven't really been using them myself. But that changed for me recently when I was introduced to React Native. So React Native allows you to build apps for iOS and Android devices using native APIs and UI elements, but it's controlled via JavaScript and React. So some of the code might look like this. It's a contrived example, but I have a view with some styles on it. I have some text with some styles on that. And it's a general React component, but I'm not using divs and p tags. I'm not using like hrefs and all that fancy HTML stuff. Views and text components and all of that type of stuff, these are the primitives of React Native applications, not HTML DOM nodes. And the styles are something like this, so it's kind of similar to CSS in JS, but fundamentally it's using the flexbox layout mode, not the box layout mode that you might be used to in HTML. So it's kind of similar but different at the end of the day. And if you're not familiar with Flexbox, a good friend of mine from Hamilton, Canada, put together this series called What the Flexbox. Definitely check it out. It was very useful for me when I was learning Flexbox. So check it out if you want to learn more about Flexbox. So now that we have a very basic understanding of React Native and kind of the primitives used to build React Native applications, how does that actually handle multi-platform apps? I mean, how is this different than like write once, run anywhere frameworks that I mentioned before? Well, it's a philosophical difference. I mean, with React Native, you're kind of expected to drop down and address the platforms individually. Like you're not expected, like React Native itself won't just handle all the multi-platform for you. You're kind of expected to do that on your own. You're kind of expected to know how that platform works and to address that platform individually. So it's not going to just kind of cross-compile. It's not some sort of shared library code. It's not going to guess at what you want to do. It's up to you to explicitly do it on your own. And that's the difference between React Native and write once, run anywhere frameworks. And the way that it does this is by overloading simple modules with platform-specific functionality. And a very simple example of that is something like this, where on iOS, for example, we want the height to be 200, and everywhere else we want it to be 100. So we can pull in the platform API, and if it's iOS, we can say height being 200. So that's kind of a simple kind of if-else statement that I kind of made fun of just now, but you can do that with React Native as well if you want to. A more complex example is something like this, where we have different modules entirely for different platforms. So we can basically suffix the module itself with .ios.js or .android.js, and when we go and require that module, it will then load the appropriate file based on the platform that we're running on. We can take this one step further by saying, just a generic bigbutton.js. So on iOS, it'll load bigbutton.ios.js. Everywhere else, so on Android, it'll load bigbutton.js. So we can kind of use the file naming to kind of target which platform we want that code to be shipping on. And in this way, we can target different platforms on React Native. So in practice, we found that very useful when developing our conversation view. I mean, this is a very complex view. And we started out with a React Native list view, but quickly found that list view wasn't really performing how we wanted to perform. The scroll was all kind of screwed up for like a convo view. It's great if you want something to scroll top down, but bottom up, it wasn't really performing. And as the data changed behind the scenes, it was kind of like jumping all over the place. We want to be able to control that scroll in that view like ourselves. So what we did was we introduced in convoscreen.ios.js. We built an iOS native component first, and we can ship it just alongside the existing convoscreen.js. Then later on, we built one for Android as well, and we can just ship that on its own. But fundamentally, the caller doesn't have to care. It's just loading a module at the end of the day. It doesn't care about if it's iOS or Android. It's just kind of loading a module. So cool. I just talked about iOS and Android. But if you just heard Ellie just now, or in my talk description, I talked about all these 6 other platforms. So how are we actually doing that for all of these? How are we actually targeting web, Mac, Windows, Linux, iOS, and Android? I mean, I'm sure you can imagine like those platform differences are absurd. I mean, the basic example is navigation. And on Android, there's a hardware back button. On iOS, it's generally handled via software. But on web, there's a back button, there's a forward button, there's a refresh button, there's a URL bar, and there's a history dropdown. Right, so how are we handling those types of concerns from the same code base? There are hardware differences. I mean, some devices might have different hardware than other devices. How are we handling that within our code base as well? There's user input differences. I mean, MacBook Pros just introduced a touch bar. How are we handling that user input differently on some platforms, but maybe other variations of user input on other platforms? And we haven't even talked about screen sizes yet. How are we creating the same experience for a mobile phone as we are for a large desktop display, kind of like that one? That one's pretty big. And there's a whole myriad of other cross-platform issues, such as linking, external linking, deep linking, access to hardware, which is available everywhere but web, notifications, which are implemented differently. I mean, there's a whole bunch of other issues, and especially online, offline, although I might have a solution for that now, thanks to Yanni. But it's obviously quite useful when it's quite important, when you're talking about mobile applications that are constantly changing their connectivity. And so you might be thinking, isn't React Native only for mobile? I mean, how are we doing this on anything else? And yes, you are right. React Native is only for mobile. But React is super powerful. And Sebastian Markbage gave a talk a little while back about Dom being a second-class citizen. So can we kind of use the concepts he was talking about in that talk to kind of build something like React Native for everything else? Can we just build that ourselves? Well, the good news is that we don't have to, because this guy, Nicholas Gallagher, did it already. He built React Native Web. So what this does is it basically provides the same type of React Native primitives like views and text elements and image tags and all that fun stuff. But and you can use that to build your app, but that will drop down to like divs and p tags and all that fun stuff that we have in HTML. And so you can technically create an entire experience using the same code base that will just drop down to whatever platform that you're building on. And I'm not sure about you, but I'm a skeptical guy, but when I heard about this, I'm like this guy was like drinking or something when he came up with this, because it must not be very stable. But it turns out that Nicholas actually works at Twitter, and mobile.twitter.com is built off of these technologies. So if Twitter has enough confidence to ship this to production for their entire user base, it must be pretty solid, right? It must be pretty good. And so we thought we'd try it out. And at this point, I can see a few of you are a bit confused or a bit like you don't really know what's going on and maybe not quite sure about all this. So let's just do a quick recap. So to recap, we started out with React. So React is a library for the web. It's built for the web, and they initially shipped it for the web. And then from that, we came up with React Native. So that's the mobile library. It was based off of a web library. So now we have React Native Web, which is a web library that's based off of a mobile library that was initially based off a web library. All right, so everyone with me so far? OK, I see everyone kind of, they're not confused anymore. I just cleared that up, which is great. Thank you. All right, so now that we kind of talked about the UI and how to tackle the UI part of this, how does this actually execute? Like we know how to build the UI, but how do we actually run this thing on all these different platforms? I mean, it's a different environment on literally every single platform. How do we actually execute this? Well, the good news is for iOS and Android, we can just use React Native. They have a great bundler. They have a great packager. We can just package everything up using React Native and kind of ship it like that. With web, we can use kind of traditional tools such as React Native Web, React DOM, and Webpack. And we can kind of use that to package our app for web. But there's no such thing as like macOS React Native, or Windows React Native, or Linux React Native. There's nothing like that. So how do we actually run on these platforms? Well, the good news is that there's something called Electron, which basically just wraps Chrome within a desktop window. So therefore, we can target those platforms by basically just wrapping our code inside Chrome, which is already supported via web, and shipping it for those platforms. And therefore, we can use React Native Web, React DOM, and Webpack again on top of Electron to target those platforms. That's how we can actually execute on all of these different platforms. So then how do we handle the cross-platform specifics? I mean, I went over how React Native does it, but how do we handle that for all these other platforms where we don't have React Native? Well, the good news there, again, is we can do it in a similar way to React Native. I mean, since we're using Webpack, and Webpack you can configure to do anything on the planet, I'm convinced at this point, it has this resolve order. So on macOS, we can define a resolve order kind of like something like this by saying macOS.js, look at .macOS.js files first, then look at .desktop.js files next, and then look at ordinary.js files. On Windows, we can do something similar, but prefer .windows.js before desktop and ordinary.js files. And we can use this type of approach to kind of address the whole myriad of platforms we want to address and all combinations and whatever modules you want to address in whatever way, because Webpack's super configurable, as I mentioned. We can also then alias things like React Native Web to React Native. So when we go and require React Native, it's actually requiring React Native Web. And in that way, we can use literally the same code, just re-alias them. And we can, like literally the same code can then just require the models appropriately. And we can do this for any other platform-dependent module, such as maybe a notifications library or whatever. We can just alias them appropriately to either no-ops or platform-specific versions. So an example of this in practice, we can take, like, let's say, linking in React Native, which is used to link externally to like URLs and stuff. Linking.js can just be a re-export of linking from React Native itself. For desktop, we might want to use Electron's external linking. So basically just override the open URL function and open it externally via Electron. And on web, you might want to open that in a new tab. So we can do that with a linking.web.js and just open that separately in a new tab. And what we found is that this is great for the bread and butter of our application. I mean, the vast majority of web developers, let's face it, we're building forms all day. We're putting data in lists all day. I mean, we aren't building like the world's most interactive, like crazy OpenGL thing. We're just like putting things in other places, and that's basically what we're doing. And we don't really need native languages to do this. In practice, we found a lot of our time and energy goes into making these views, and on the surface level, they look kind of simple, but underneath that, they're kind of complex. There's a lot of business logic going into this. And since we're able to share code across platforms, we can write the logic once in React, which I love, and have an immediate client impact across the board. I mean, basic JavaScript and components can solve this problem and address every single platform that we support. I mean, would you rather build something in React or build something in some NS Objective-C garbage? Or build something in some public static void Java bullshit? I mean, really? I'd rather just write React. I wouldn't want to drop down to any of those languages. And so, cool, we've gone over how all this stuff works. I've kind of shown you the UI layer, how to physically execute it, gone over kind of like how to link and like how to override certain modules and all that fun stuff. But a question I have is, why does this work? I mean, why does this work on React but didn't work for all those other like write once, run anywhere frameworks? I mean, surely they can just do kind of like some sort of module overloading thing as well. I mean, why does it not work for them? Well, one of the reasons I think is because of the React component interface. And here's kind of a contrived example, but we have a platform-specific mobile JS file where we're doing something on mobile, and then we're inserting that into like some sort of view. And here's some somewhat equivalent on web where we're doing something on web and we're inserting that into a div. And fundamentally, those two things are doing like whatever is appropriate for their platform, doing something very specific for their platform. But they're composed into our app. And our app doesn't have to care at all about what it's doing. All it has to care about is where to put it inside our application. right? I mean, like our app knows that that's another React component. It lives by the React lifecycle. It has a constructor, it has a component did mount, component will unmount, component will receive props. It's receiving data in the same way that all other apps, all other components in our application are receiving data. It's getting handled through the same mechanisms as everything else in our app is getting handled. I mean, it's working just like any other React component because it's the same interface as any other React component. And in this way, it's immediately as composable in our application as any other React component is because it is just a React component. And I think for this reason, this is why React and React Native has done it right, and why they've done it in a way that I'm not really skeptical about and I like to use, is because it's just another React component. So now that you know what to do, you can go ahead and do it for all the things. I mean, you can use React Native's Dimensions API to kind of like measure the screen size and address the different screen sizes across the board. You can use push notification libraries to kind of push different notifications to your front end. Like you can use various amounts of different libraries across the board by overloading each platform specifically and abiding by the React component interface to kind of address them all and compose them all inside your application. And at Mainframe, what we found is that we've been able to share about 95% of the code on our platform by doing this. And this has eased automated testing dramatically. I mean, we can just like test one thing and that's basically it, right? It's a way better developer experience. I mean, you don't have to have like a native team over there and like a wall in between them and like, you know, like front end, like JavaScript developers over here. Like everyone's just part of the same team. We don't have to develop things like n times depending on how many teams we have. We develop it once and then we ship it once. We can hire fewer developers to accomplish the same result. I mean, would you rather work with a small dedicated team or a bunch of project managers, right? And faster development time means faster time to market. So we can actually ship faster. We can get this stuff in the hands of our clients faster. And speaking about clients, they have the ability to pick up any one of our devices and have the exact same experience. So they can pick up an iPhone, they can go on their Mac, they can go on their Windows machine, and they have the exact same set of features that work in the exact same way and all behave exactly how they would expect it to behave. So our customers love it as well. But if anyone tells you that everything's great and amazing, there's no downsides, you call them a liar. So here's all the caveats with this approach. Basically what we found was that manually testing this as a developer is a bit time consuming. So basically I build for one platform to test if it works on every single platform, right? If I build something for web, I need to test iOS and Android. And let's admit it, no one likes opening up an Android simulator, so it's a pain. And Windows, and like I need to test all the platforms. That's kind of a pain whenever I ship something anywhere. I need to kind of ensure that it works across the board, and of course we're lazy. We just leave the QA team to do it. But it's the reality of this type of approach is we're changing literally every single platform whenever we make a code change. And we can't really ship a feature until it works across all those platforms, all right? If it breaks something on one platform, we have to fix it on that platform before we can ship this feature. What I noticed is that React Native Web isn't quite 100% compatible with React Native. I mean, there are small API differences between these libraries, and when you're building apps that kind of rely on how these things function, those small differences can add up. It's okay in our experience because we can just drop down and write a platform-specific variant and just kind of avoid all this, so we can get around it that way, but I thought I'd mention it anyway. One of the things that recently I'm working on is that React Native 43 just released a flat list and virtualized list, which is a much better list view, but React Native Web doesn't have it yet. So I'm working on an actual contribution to React Native Web to bring that back to React Native Web, and then we'll have feature parity, so then we can upgrade. So that's another downside of this approach, is that we're kind of limited by our tools at the end of the day. And then lastly, but certainly not least, is that Flexbox has issues on some browsers. I mean, older versions of IE have issues with Flexbox. And interesting question, why do they call it IE? Because that's the sound developers make when they have to work on it. And so, like because of this, like we can't really ship Flexbox to those browsers, of course. I mean, the good news is that modern versions of IE or Edge or whatever it's called now, and everything else basically supports Flexbox, so we can have like feature parity across the board. But older browsers, they don't really support it. There's some issues, there's some workarounds, but then you have to test every single platform again. So these are some of the issues with this approach. So at Mainframe, what we did was we focused on the platforms that our consumers want the most. I mean, what we found is the biggest consumer impact will be done on iOS, Android, Mac and Windows. And so we've kind of limited our amount of platforms to those because those have the biggest client impact. And it also creates happy developers. We don't have to test across every single thing every time. We don't have to test across Chrome and Safari and Firefox and iOS and Android. We can just test across like this constraint set. Perfect. Well, thank you very much. Yes.
Hey, how do you deal with platform-specific libraries or features like service workers?
How do we deal with platform-specific libraries such as service workers?
No, how do you import platform-specific libraries, or how do you use native environment kind of features like service workers?
So it's like service workers already exist in the JavaScript environment, right? So like you basically just pull that into your module as you would with anything else. And then you would just overload for those specific platforms that have it. You would then introduce basically certain modules for those specific platforms, pull it in there. Platforms that don't have it, you might use something else in order to kind of mimic a service worker like API. But since you're able to just overload, you can just kind of say, I want the native implementation on those platforms, I want my own implementation on these platforms, or I want it to do nothing on those. So in that way, we can just pull it in whenever we want. In the example I gave kind of earlier about the conversation view, we just literally wrote like native components. We just wrote like native functionality for that combo screen on iOS and Android. And we can just wrap that within a React component and just pull that right into our React app. So in that way, we can just kind of target each platform individually. Yes, Mr. Lorenzo.
One of the things I saw in your slides is like you're already using Webpacks for 2 of your inputs, like not for React Native. But now with all, do you think are you going like to have one single Webpack config that's going to work for everything?
So like with Hall, can we have a single like holy shrine of Webpack config that we don't have to configure once and can magically work? I think like yes and no. So I think yes, because with Hall, I'll be able to kind of share parts of a Webpack config, but we can't share all the Webpack config. So we can definitely kind of reuse parts of it, such as actual resolve orders, such as like things like the aliasing, things like that we can possibly reuse. I mean, one thing that drives me nuts on React Native without Hall right now is kind of like the .. / and like I have no idea where I am in life anymore. So like kind of just having it to go like like front up would be great. So just having Hall for just that would be amazing because I have it everywhere else. But I mean, fundamentally, to answer your question, I think we can share parts of the configuration with Hall, but we can't share all of it with Hall. But Hall would definitely help unify things. Yanni.
Have you either discovered or internally developed any good abstraction for like adaptive UIs? Like using Flexbox and React is great for creating UIs to work across different platforms, but sometimes you actually want the UI to be different. So you could either go ahead and do like entirely different componentries, or you could have like adaptive layer in your code. So you have something for that.
Yeah, so we do have something like for that across mobile and desktop right now. Because on like mobile, obviously it's a small constrained screen. On desktop, it's a larger screen. And on like things like tablets, it's also kind of a larger screen. So we do have kind of a layer that kind of like measures the screen size, and then we'll display a different kind of layout depending on the screen size. It is all using the same technologies under the hood. I mean, it is all using like React and Flexbox and React Native Web. So they're using the same technologies. Just the actual like rendered like output is different. And we do that just by measuring the screen size. Thanks. Yes?
How many developers do you have, and like do you have like a specific person for each platform, or is it kind of like the whole team shares responsibility for?
Yeah, that's a great question actually. So how many developers do we have working on this, and is there a certain developer for each platform that kind of like targets each platform? So how many developers do we have right now? We have like I think 10 developers total, like some back end, some front ends, about 50-50 split between them. Like there is definitely platform expertise amongst the front end. Like there's one developer that we did previously have working on native code and then native iOS code, and then he kind of switched over now since we're using this framework, this type of approach now. So like he'll work on like iOS specific native UIs and stuff, and we have someone on Android working on Android specific things, and there's nobody in our office that uses Windows, so hey, whatever. like we do have kind of platform expertise in that way. That if there is kind of native code, they'll work on it. But again, as I mentioned before, like 95% of our code base is shared and it's JavaScript. I mean, when they'll go in and actually do something on the native side, it's like slim to none. We don't have that much native code for it to really be like we have one person dedicated on this because a lot of it's shared. Yeah.
Have you noticed any inconsistencies between within Electron in different environments, like between Mac, Linux, Windows?
Have you noticed inconsistencies in Electron between environments? Not really, to be honest with you. It's been pretty consistent. I mean, yeah, I'm not sure what more to say there. It's worked for us. Like we're not like the heaviest users of Electron, you know, like we aren't using every which individual like deep API there is. So I'm sure someone that is might find some inconsistencies there. Like we're using it in a relatively light way. But for us, we haven't run into any issues. Yes.
Do you use Pusher for push notifications?
Do we use Pusher for push notifications? Well, I'm afraid we do not. Our backend is actually using Elixir Erlang, and we've done a lot of effort into creating a fully real-time API because our app is fundamentally a communications app, so it has to be real-time, it has to be snappy. So since we have an entirely Erlang-based Elixir backend, everything's a WebSocket API, we just built it ourselves. Yes?
What do you use for routing and navigation?
What do we use for routing and navigation? That's a great question, and there's a lot of different options out there on the market right now. Right now, we're using a mix between a custom forked of navigation experimental for React Native, and then we re-implemented that for desktop. But we might want to throw it all out and just put in React Router. But there's some debate about using React Navigation, and so honestly, it's kind of we're navigating that right now, and I don't really know where to go. Yeah, my preference is React Router, but everyone has their own. So yeah, we're not sure yet. Yes.
Do you have any tips for integrations like end-to-end testing?
End-to-end testing. That's a great question. Yeah, I mean end-to-end testing is kind of difficult. Like what we found is that because we have a mix of like JavaScript code and we have a mix of native code, our best end-to-end testers are just people. It's a terrible answer, but that's what I found in practice. I mean, it hasn't been the case just for mainframe. In the previous companies as well, it's been, you know, people are the best end-to-end testers. We have automated testing for the vast majority of things, so we can kind of catch issues before it gets to them. But at the end of the day, they'll be able to find all those edge cases, and like they'll be able to type in like negative like 3.1486 in something that should only be positive integers. Like great, you know, like they're the people that can do that. In practice, that's what I found.
So would you say most of your tests are unit tests then?
The majority of our tests are unit tests, yeah. And by majority, I mean all of our tests, yes.
Thanks.
No worries. Any other questions? Yes.
So React Native Web has a set of primitives. What did you extend that? Like, did you add new buttons on top of that? Like, and how much work was involved in that piece?
Yeah, so like React Native Web provides some primitives, and like it's not complete feature parity with React. React Native Web isn't complete feature parity with React Native, and so there's kind of a difference there. Like the way that we look at it is that in order to build for these platforms, we're gonna have to build it anyway. So if we can just build that and share it across platforms, it's still a net gain. I mean, we're still not building it like n times for each and every platform. So like sure, we might have to do some additional work to kind of build it to basically extend React Native Web's feature set to be a bit more in parity with React Native, but we still see it as a net gain because we can share that code across different platforms. It's like, yeah, like flat list and virtualized list is a perfect example, right? I mean, like there we had to extend it. Like I'm literally writing, like my day is literally writing tests on flat list and virtualized list for React Native Web so we can have parity there. So like, but again, it's still a net gain than implementing it n times across every platform. Yes?
Do you actually need a flat list implementation for web? Like, couldn't you use, like, just have your app-specific list view implementation that just wraps, like, React virtualized on web and then wraps, you know, like, flat list on native? Like, do you need to bring that down to very native web level?
That's a great question, Yanni. Do I have to do what I'm doing right now, or or can I spend my days drinking with Yanni? While I would love to grab a drink with Yanni, maybe we can do that after this. Basically, as I mentioned before, like we had to kind of build our own kind of list view implementation for the Convo screens, and the main reason there was kind of unique to us, and that was because a lot of these list view implementations they're kind of powered from the top down, and every single messaging app you use is bottom up. I mean, you type a message and you don't like kind of like jankily re-scroll your entire view. It's just there. And so this is just one reason why we kind of had to build our own kind of list view implementation. Another few reasons. I did evaluate React Virtualized, and React Virtualized is fantastic, and I'm sure like if you can use it, great. But one thing I noticed was that it really wants you to give you all the heights up front. And if you don't know what the heights of your things are up front, if you don't have like a perfectly like grid list, if you have like kind of a free-form list where views take up however much space you want to take up, it doesn't work so great. Something else I found was like the scrolling, the scroll points in React Virtualized wasn't that fantastic either. I mean, it could be improved. So the implementation that I have improves on those things. It still has a way to go to really match performance of React Virtualized and all of that fun stuff, but I'm focusing on kind of the feature set first and then kind of performance and all those things later. But I guess going back to answer your core question, it's kind of, it doesn't work that well for us. And so for us, we have to build this anyway, and so we may as well build it in a way that can work for React Native as well, and we can just kind of share code again. Yes?
Do you have any open source software?
Do we have any open source software? Well, let me tell you about that, Ellie. So that's my next talk. I recently just open sourced Relay Compiler Webpack plugin, so that will compile all your Relay Modern queries inside Webpack. Flat list and virtualized list, I'll be open sourcing that as well, of course, on React Native Web. There's a few other things I've open sourced, and we've open sourced as mainframe. So I guess, yeah, check out like Taz Singh on GitHub and things, and you'll see it all in there. Does that answer your question?
Yes.
Cool. There's a question back here, yeah?
Yeah, I just wanted to say that, like, if React Virtualized doesn't work in some cases, it would be great if you could phrase an issue, because I know Brian is kind of jaded from some more boring parts of work on React, and sometimes he just wants to like hang on React Virtualized, so it would be great to highlight the issues that we have.
Just align the issues there with React Virtualized. Yeah, you're probably right, and I think we did take a look at React Virtualized and the issue tree, and it wasn't part of the philosophy of React Virtualized to support those types of issues. But we did look at that first, yeah. Yes?
So do you have any problems supporting different versions? So React Native has a kind of faster version cycle, so it depends on 16, React 16 Alpha 4 or something. But you have web code which depends on maybe React 55. So is there any issues around that?
That's a fantastic question. I don't think I'm the best guy to answer that. But what we've done is, well, first of all, the first thing I tried to do was upgrade React Native Web to 16, and that was a pile of tears. I mean, it just didn't work out very well. React 16 isn't ready for that yet, in my opinion. So next thing we did was we looked at the parts of React Native that we cared about. So in particular, flat list and virtualized list. The good news there is that it's pure JavaScript implementations. So we could just port that back to React Native 42, so the one that doesn't have 16, and kind of use it in there until the entire JavaScript ecosystem. So the problem wasn't React Native Web in particular. Problem was things like Enzyme. Like there's no test utils currently in 16 based on when I last checked. So therefore Enzyme is kind of broken. So you have to build a custom React 16 with your own test utils and then get that to work with an Enzyme, and then Enzyme breaks because it's not ready for 16. So it's just until the ecosystem is kind of ready. Then I think React Native Web will be able to upgrade to 16. But what we just did was just backported things, and yeah, that worked. Cool. I should probably be cut off soon, otherwise I'll be here like all night.
So yeah, hang out. Thank you to all our amazing speakers. Thank you.